Okay, so I'm on page 35 of your guys' packet, right underneath the answers to binomial theorem practice. And I'm going to go over an example for binomial expansion. Now, this problem is going to be pretty lengthy, and I recommend having 3 different colors out. It's really going to help you guys understand this concept. So that's what I recommend. You don't have to have it. So it's called binomial expansion because this is a binomial. We have 2 terms here, and we're going to expand this out. Now we know that we cannot distribute this 5 because of this addition sign. Do not distribute it. So this would be 2x plus y times 2x plus y times 2x plus y times 2x plus y times 2x plus y, and that would take us forever. So there's a faster way to do this, and it's a pattern that we have to learn and be familiar with. So I'm going to talk about the pattern right now. Now the first thing that I want to talk about is what's called Pascal's triangle. And what Pascal's triangle gives us are the coefficients in front of each term, our coefficients of the answers. So here's what you always start with Pascal's triangle. And on a test, I would want to see this triangle. So I start with 3 ones like this that are in a triangle. Okay? So we start with 3 ones. From there, each new row that I'm going to make in my pyramid, I start with a 1. You will always start the new row with a 1, and you will end with a 1. Okay, so I start with the 1, and my 2, whatever is above, so I have 2 1s above here, so I'm going to add them. So 1 plus 1 gives me 2, and I put the 2 in the middle below. And I end the row with a 1. Starting my new row, I start with a 1, and I add what's above. So I'm adding 1 plus 2, which gives me 3. I add what's above. 2 plus 1 gives me 3, and I end with a 1. Adding a new row, I start with a 1. I add what's above. 1 plus 3 is 4. 3 plus 3 gives me 6. 3 plus 1 gives me 4, and I end with a 1. Adding a new row, I start with a 1. I add what's above. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And I end with a 1. My new row, I start with a 1. I add the 1 and the 5 and I get a 6. I add what's above the 5 and the 10 and I get 15. I add what's above the 10 and the 10 and I get 20. I add what's above the 10 and the 5 and get 15. I add what's above the 5 and the 1 and get 6. And I end with a 1. So you can keep going throughout this whole triangle. Okay, so we're starting with, this would correlate to a plus b to the 0. So when the exponent is 0, this is when the exponent on a plus b is 1. A plus b exponent is 2. Exponent is 3. Exponent is 4. Exponent is 5. Exponent is 6. Okay, so if this is not making sense right now, I'm hoping that it will make sense at the end of the problem. Okay, so we know the pattern now for Pascal's triangle, so we're good to go. Now, in this problem, my exponent is a 5. So because my exponent is a 5, I'm going to go to my Pascal's triangle that I know the pattern for. I started with my 3 1s and then added. And I'm going to go to a plus b to the 5th. So it's actually the 6th row. So 1, 2, 3, 4, 5, 6. It's a 6th row, but here I know that it's going to be 5 because I have 1, 5. And that's kind of how I memorize it. So 1, 5. So I know that that's my exponent here. So I'm focused on this row. This is the row that I want because my exponent is a 5. So I'm going to write my coefficients out. I'm going to have 1, and I'm spacing them out as much as possible because I'm going to need space. 5, 10, 10, 5, 1. Okay, so I spaced out, these are my coefficients, and now I'm done with this color. So if you're using your colors, we're done with the green. We got our coefficients. Now for my other color, I'm going to deal with the first term here. So my first term is 2x. So on my very left-hand side, my first coefficient, the pattern is I start out with 2x to the 5th power. Now why do I start with the 5th power? Because my example is to the 5th power. And each new coefficient, I'm going to decrease my power by 1. So I'm going to have 2x to the 4th, and then 2x to the 3rd, and then 2x squared, and then 2x to the 1st, which to the 1st I'm just going to leave alone. And then I should run out by this one. This is like 2x to the 0, but anything to the 0 power is 1. Okay, done with that color, done with that problem. Do you guys see 5, 4, 3, 2, 1? Now I'm going to go to my third color, and I'm going to go to this second term here, y. And now I start on the right side, because get it, this is the right term. The left term, we started on the left side, so the right term, now I'm starting on the right. So I have y to the 5th. I'm starting at the 5th, because that's my highest exponent. And then I have y to the 4th. Then I have y to the 3rd. And then I have y squared. And then I have y to the 1st, which I'm not even going to put a 1 there because I know it's just y. And then I run out. So the very last step is just adding all of these together. And if I were to have multiplied out those whole 5 things, 2x plus y times 2x plus y times 2x plus y times 2x plus y times 2x plus y, and took forever to multiply it out, I would have gotten this entire answer. So it's actually a lot easier if you guys learn this pattern and you don't have to multiply everything out. Now, I would want to simplify this further, so you could simplify all of this further. I'm just going to give an example of simplifying one term just in terms of time. And a lot of times the questions will say, what is the third term after expanding? So this is my first term, this is my second term, this is my third term. This would be my fourth term, my fifth, my sixth. So I want my third term here. So I'm going to rewrite this down here. So 10 times 2x to the 3rd power times y squared. And now I'm actually going to simplify this and figure out what my third term is. So I'm going to distribute my exponent here. So I'm going to have 10 times, let's see, 2 to the 3rd. 2 times 2 is 4. 4 times 2 is 8. So that gives me 8x cubed times y squared. And then I have 10 times 8, which is 80. So that gives me 80x cubed y squared. And that would be my third term simplified. So that's what these questions are going to ask. If you guys look at page 33 and 34, I want you guys to give those a shot based on this example, and there will be a couple more videos posted. Good luck!